Calculus kids, this is Dr. Callahan with week 13 Tuesday. How are you guys doing? Go ahead and pause the video, answer the following 3 questions for week 13 Tuesday for your warm-up blog. All right, so let's go ahead and take a look at your guided notes for this class today for week 13 Friday. It is actually going to start in your guided notes right over here. So here you have 2 questions from the actual free response portion of your AP exam, and I'm going to try to go over at least one a day with you guys between now and week 19 Monday, which is the day of the test on May 24th at 8 a.m. And so with from now on, with each of these questions that we go over for the review, there's always a link that says need answer. Here it is in the link above, and you just need to go ahead and click on it. However, you do need to download Dropbox first, so make sure you have that available. And that way you can see the steps with these questions that's given to you. Here is page 2, which goes over the concepts of curve sketching. Page 3 are some of the questions from your calculated questions of the actual multiple choice question portion of the test from previous exams. Page 4, and that is basically it. So 4 pages. In addition to that, yesterday, which was week 13 Tuesday, I had you guys go ahead and stop your Math Excel and basically look at your Albert IO in addition to your Princeton review book, because that's going to be your assignment from now on. So let me go ahead and just pull up that so we can take a look at it. And in case you don't remember what it was, that way you can see the requirements for the remaining part of the semester for your grade. Each week, you have 2 grades going into Infinite Campus. The first grade is going to be your Albert IO, which essentially is replacing your Math Excel. The second thing is your Wednesday assessments, which I haven't decided what resource I'm going to use just yet. So eventually I will definitely let you guys know that as we get closer to Wednesdays. But for now, just focus on your Albert IO in addition to your Princeton review. So looking at this right here, just making sure that we're on the right page. As a review, these are all the units that are going to be required for you to go over for all the units that we talked about since August. Now, instead of doing Math Excel for week 13, which I've already stopped that, your Monday, Tuesday, Wednesday for week 13, so today is week 13 Tuesday, is to pick any 30 questions out of 133 for the Unit 1 limits and beyond. And then we're going to start Unit 2, which is on derivatives, this Thursday and Friday. You have until Sunday. So for these 2, it's due by Sunday, 11:59 p.m. So you do have Saturday and Sunday to catch up on that if you need to. And then, of course, Unit 3 is differential techniques. Unit 4 is application of derivatives. This is week 14, which is going to do by Sunday, 11:59 p.m. of week 14. And then week 15 is going to be the applications of max and min. So you're going to focus on that on Monday, Tuesdays, and Wednesdays. And then if you look over here, I have the first practice exam. It's 51 questions, and it's going to be exactly aligned to the actual AP exam with a number of free response questions with a calculator, number of free response questions without a calculator, and then multiple choice question with a calculator, multiple choice without a calculator. There are 51 questions. It is going to expect to take you about 3 hours and 15 minutes, and I know that's going to be quite long, but when you take the actual test, it really is going to be this long as well. So you have all of week 15, Thursday, Friday, Saturday, Sunday to complete it. This is going to be due on week 15, Sunday, and you guessed it, 59 p.m. Then we're going to start with Unit 6, Integration, Introduction to Integration. You have 30 questions to pick anywhere between Monday through Friday, although I might change that to 60 because we have the focus of this for the entire time. Unit 7, which is differential equations, slope fields, which is 17 Monday, Tuesday, Wednesday. Unit 8 applications of integrals, area under a curve, volume, velocity, acceleration. That's going to be week 17, Thursday or Friday. You can pick any 30. And then the last week, which is week 19, Monday through Friday, the only thing I want you guys to focus on is your second exam, which is going to be 51 questions, just like the first one, except it's a different version of it. But it's just like taking the actual AP exam, and it is there to prepare you so that way you could take like a version of it before taking the actual test on May 24th, and you have the entire week to do that. Now, you don't want to do this on week 18 Sunday because you're taking the test on week 19 Monday. So do pace yourself, get it ready, get it done, and then that way you can kind of mentally prepare yourself for the test on Monday, week 19. All right. So my suggestion on what you should be doing for week 13 is do your unit 1, pick 30 for Abra.io. Take a look at the printed review book for unit 1. Read the notes and examples on limits, especially if on some of the questions you're not understanding. I know it's been a while since we've done limits, discontinuous limits, limits that go to does not exist, limits on with 3 different methods of solving by a graph, a table, and analytically. And with it analytically, you can either factor it, multiply by the conjugate. You can go ahead and divide it with long polynomials, synthetic division. So all the techniques that we talked about succinctly in talking about limits. And then Math Excel, which is week 1 to 12. If you have not completed anything of everything there, you have 100 points that you can go ahead and do. And then AP College Board, week 1 to 12 redos. So you can go ahead and redo that as well. So those are the 4 things I would suggest that you focus on. Okay, so with that said, yesterday I gave you guys a concept sheet with the formulas of all the things that you need to memorize, and we made flashcards in class. And actually, no, I had you guys highlight it. Just kidding. Yeah, we did highlight it. So yeah, all right, with that said, let's go ahead and take a look at your breakdown for today. I do have a Kahoot on limits, but this is online, so you won't be doing that. But I will give you guys a Quizlet on that before you guys leave. We're also going to go over my review on true free response questions in class, just so you guys kind of get the hang of how to do this. So we're going to start off with the first one right here. Go ahead and pause the video and read the question so you're familiarized with it. All right, so the rate of consumption for Coca-Cola in the US is given by this equation. And as you can see, it has an E function, E to the KT, and where S is measured in billions of gallon per year, and T is measured in year from the beginning of 1980. All right, so part A says the consumption, and this is the one where you actually get to use a calculator. So our calculator is okay. The consumption rate doubles every 5 years, and the consumption rate at the beginning of 1960 was 6 billion gallons per year. Find C and K. And this is a question back in 1996. I know that was a long time ago, but quite frankly, it's like there's only so many different variations, excuse me, of the same type of question they can really ask. So once you understand the first variations of it, it's pretty much the same after that. You just need to make sure you understand that. So let's go ahead and set this up. So I'm going to use T for time. And then let's do S of T for consumption of Coca-Cola in gallons. Okay, it's also given to me that in 1980, the consumption is 0 and the rate doubles every 5 years. And at the beginning, it was 6 billion of 1980. So that gives me 2 points. So when time is equal to 0, I know that the consumption was 6, and that 6 is going to be in 6 billion gallons. Okay. And then it says that at S of 5, it is going to double every 5 years. So if it's going to double, that means that 6 gallon then becomes 12 gallon. So those are the 2 points I'm going to be working with. Then let's take a look at your equation, which is given to you at S of T. is equal to CE to the KT. Or my goal is to solve for C and to solve for K. So let's go ahead and use the first point, plug it in, and the first point you're going to use is going to be with the T equals 0, because then I don't have to worry about the K, and I can just simply solve for the C. So then in that case, 6 equals CE to the K times 0. Well, that cancels, and that's just going to give me a 0. So e to the 0 power is just 1, so your C equals 6. Well, that's easy enough. Well, now let's take that and plug it back into the original equation. So S of t equals 6e to the kt. Now that I went ahead and found C, let's go ahead and find K. So that's when I use a second equation. So 12 equals 6e to the K times 5, because in 5 years, the gallon doubles. And so here you're going to use your calculator. 12 divided by 6 is going to be a 2. ln both sides, so ln2 equals ln e cancel, so 5k. K equals ln2 over 5. You want to put this into your calculator, and you should get a decimal of some sort. And whatever that might be, I'm just going to use ln2 over 5 because I don't have a calculator. So then your equation is going to be S of t is equal to 6e to the k. Your k is a ln2 over 5t. A, done. Now let's go ahead and take a look at B. So for your B, it says, find the average rate of consumption of cola over 10 years, beginning of January 1st, 1983. Indicate the units of measure. So then for this one, if you're looking at it, it's going to be your average rate of change, which is 1 over B minus A, with the integral S of t to the dt. And your integral is from A to B. All right, well, let's go ahead and plug this in then. So looking at this, your B in this situation is going to be from 1980 to 1983. There's a difference of 13 years. And then, of course, your A is going to be 3. Your A is from 1980 to 1983. And then your B is going to be from 1980 to 1983 plus the 10 years. All right, so then let's go ahead and rewrite this. And I have the integral from 13 to 3, or whoops, 3 to 13. Lower bound comes first. S of t, which you found is 6e to the ln2 over 5t dt. So if you go ahead and integrate this, and you actually would just go ahead and plug the evaluation of this in, you should have 19.680 billion gallon per year. All right, so then for C, it says use the trapezoidal rule with 4 equal subdivisions to estimate the integral between 5 to 7. I think that's a 7. Hold on a second. Yeah, that is a 7. So the trapezoidal rule is going to be, well, if you look at it, it is going to be, remember this, I'm trying to remember this. So here's your height, base 1, base 2, your area is going to be 1/2 times the height, base 1 plus base 2. Okay, so that's how you find the area. I need to figure out how many of these trapezoids do I have. So to find the n, you have to take the two different measures, b minus a over, and let's see, does it tell me 4? There we go, 4 over 4. So that's going to be 7 minus 5 divided by 4. And that's going to give you a 1/2, which is 0.5. Okay, so let's go ahead and do the trapezoidal rule. So the trapezoidal, okay, my pen is being a little odd, so let's see what's going on here. The rule of the trapezoid, come on, the rule of the trapezoid is going to be your W over 2. Your W can also be your height, okay, depending on how you look at it. So that could be your width. Width over 2. Okay, so instead of using a base, you can use height 1 and height 2. It just depends, like if your trapezoid is that way or if it's this way. I mean, either one works, you know. If it's going to be this way, remember it's base 1, base 2, height. But if it's vertical, I guess it's height 1, height 2 over width. And it's just going to be height 1 plus 2 height 2 plus, oh gosh, what is it doing this? Plus 2 height 3 plus 2 height 4 plus height 5. And then you're like, well, why are there 2 of them? Because remember, you're going to have another trapezoid on the side of this right here. And so you're literally sharing this in between twice, okay? So you're not going to be sharing the very bottom of that because after this, you have the third one. So that's going to be B1, B2, B3, this is B4. But then when you get to the fifth one, this will be B5, but there's only one B5 because you're not sharing all of them. Okay, so that's the reason why you have this. All right, so then if you go ahead and rewrite this with your integral from 5 to 7 s of t dt, your width is going to be your 0.5 over 2. And you're going to plug this in with s of 5 plus your height 2 is going to be 2 times s of 5.5 because the width is gaining by 1/2 plus 2 times 6, or s of 6, I should say, plus 2 times s of 6.5, and then 2 times 7. And that's how you will set that up. All right, I'm running out of space, so I'm going to go on to the next piece, which is going to be D. For D, it says, using the correct unit, explain the meaning of integral 5 to 7 s of t in terms of cola consumption. So you will say you could say that the lower bound is 5, upper bound is going to be 7, and s of t dt means the total consumption in billions of gallons during the years from 1985 to 1987. All right, you guys. So that is what you will have to do for this question. And as you can see, it's not just one specific skill. It's actually it's a culmination of several different skills that you will have to remember to do. Next, I want to show you guys is actually how the grades are evaluated for this. So take a look on the second page of your guided notes. This is actually handed out in class. If you didn't get it, make sure you grab one. On the left side right here are the steps. I went ahead and typed it up for you guys as well. So you can see this is how you will go about solving for this. All right, so let's go ahead and take a look on the right side. So pause the video and answer the following questions to the best of your abilities. All right, so let's go ahead and read this. So the volume of a spherical hot balloon is expanding inside the air at a balloon as it's heated. The radius of the balloon in feet is modeled twice the differentiable function of r of time, where t is measured by minutes between 0 and 12 seconds. The graph of r is concave down. The table above gives selected values of the rates or prime of t for the radius of the balloon over the time interval 0 to 12. The radius of the balloon is 30 feet when t is 5. Note that the volume of the sphere, the radius, is given by the volume v equals 4 over 3 pi r cubed. So for A, it's asking you to go ahead and estimate the radius of the balloon when the time is 5.4. Using the tangent line, approximate when t equals 5. Your estimate is greater or less than the true value. Give a reason for your answers. So as I'm looking at this right here, I'm going to have t be the x value and then r of t to be the y value. And you have time and radius. So I know that from the from the example, the radius of balloon is 30 feet when t equals 5. So the radius is 30, that's given to me. And it's also telling me that r prime of t, so the rate of change for the radius, is equal to rate of change is given by this table. So then the rate of change when time is at 5, the rate of change for the radius is going to be 2 feet per minute. Okay. So looking at this, what this is telling me is that my point is going to be at 530, and my slope, to put it in layman's term, is going to be just 2. All right, well, let's go ahead and plug this into the equation. Y minus y sub 1 equals m times x minus x sub 1. So looking at this, y minus 30 equals 2 times x minus 5. And I want to go ahead and think about this. Instead of having r and x, I want to make sure I do this based on r and t. Okay, so make sure you remodify that. Then let's go ahead and solve for r. So then my r is, r is equal to 2 times t minus 5 plus 30. And so then from here, it's given to me that if I were to estimate when t is 5.4, then I would say r of 5.4 is equal to 2 times 5.4 minus 5 plus 30. So if you plug that into your calculator, r of 5.4. So when time is 5.4, your radius is going to be about 30.8 feet. So if you have to go ahead and provide an explanation for that, you can say something like, is this going to be an over approximation or an under approximation? This is going to be an over approximation since the tangent line will be above the curve when this is done. All right. So then for B, it says find the rate of change for the volume of the balloon with respect to time when t equals 5, indicate a unit of measure. So then for B, my goal is to find the change of volume, dV over dt. You know that your volume is 4/3 pi r cubed, and t is at 5. Your rate of change is 2 feet per second. And your radius when it is at 2 feet per second. I'm sorry, when t equals 5, the radius is 30. So 5 comma 30 is the point that you're given. All right, well, let's go ahead and take a look at this then. So let's do dV over dt is equal to 4/3 pi times, these are the constant. So looking at this right here, I'm going to find the derivative of this. So bring the 3 down, r squared dr over dt. Well, that 3 and this 3 cancels. So then your dV over dt is just 4 pi r squared dr over dt. Well, it's given to me that I have a radius, which is at 30 squared. dr over dt is 2 feet per second. So then 30 times 30 is going to be 900 times 4 times 2 is going to give me 7,200 pi feet cubed per minute. And that is your answer for B. All right, let's take a look at C. Use the right-Lyman sum with the 5 subintervals indicated by the data in the table to approximate between 0 to 12 r prime of t. All right, so the right-Lyman sum, so C. Integral from 0 to 12 r prime of t dt is equal to 5 subintervals, the right-Lyman sum. So if you're looking at the 5 from the right, then you are looking at 1, 2, 3, 4, 5. Cross that out. So then I'm going to have 2, which is going to be the time times, I mean, if you really think about this, one of them is going to be the height, the other one's going to be the base to find this. Well, actually, this is more kind of like a rectangle, I should say. To find the rectangular part, it's base times height. So you would have to multiply that through. Your base in this situation is going to be 2, and your height is r prime of t, so that's 4. So 2 times 4 plus So in order to get this, you will have to first go ahead and kind of draw a chart so that we can kind of see where this is coming from. So let's go ahead and draw that chart right here. All right, so then looking at this chart, I have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay, so from 0 to 12. And then as I'm looking at this right here, when I have the bottom here equaling to 1, my change is going to be at 4. So 1, 2, 3, 4. And then from there, when my interval here is at 3, 1, 2, 3, my right-Lyman sum is going to be at 2. Next, when my interval is going to be at 2, 1, 2, my right Riemann sum is going to be at 1.2. And then lastly, when my interval is going to be at 1, 2, 3, 4, my interval is going to be at 0.6. And my last interval is going to be at 0.5. And so if you connect the dots from here, this is kind of what your graph looks like. So when I'm looking at this part to find the intervals of it, I will have my first one, which is the 2 times 4 plus 1, 2, 3, 3 times 2.0 plus 2 times 1.2 plus 1, 2, 3, 4, 4 times 0.6 plus 1 times 0.5, which if you go ahead and add everything together, it doesn't give you a 19.3 feet. So what that means is the radius of the balloon grew 19.3 feet in the first 12 minutes. All right, so now that we're done with this one here, let's go ahead and take a look at question number, letter G. Is your approximation in part C greater than or less than this? Give a reason for your answer. I would say that since our prime of t is decreasing, the approximation using the right Riemann sum is less than the integral of 0 to 12 I prime of t, and therefore it's an under approximation. So the last part that I would like you guys to go ahead and take a look at is the answer, or actually the how it is actually graded. So if you look at the points over here, 2 points if you did the following for A, 3 points for B, 2 points for C, 1 point for D, and 1 point for units if you actually include the units in B and C. So get yourself acquainted with this. All right, you guys, if you're done with this, next thing I would like you guys to do is your Quizlet, which is kind of the last part. All you have to do is just go to this link right here and go ahead and type that in with a capital F, capital V, capital P. Once you get on there, what you have is practice on limits. And so what I want you to do is just go over these 20 cards. And just practice on your desk. Once you're done with them, you go ahead and take a look at the answers, evaluate this, take a look at the answers, evaluate this, look at the answers. All right, you guys, as always, I hope you have a wonderful week. I'll see you guys next time. Take care.